Did you ever play with an Etch-a-Sketch? Of course you did. It's one of those things that you see here where you can turn this knob and turn this knob and get the trace on the screen to move. If I turn just this knob down here, then the trace is going to go left and right. Okay, not too exciting. Well, I can also turn this knob right here and the trace will go up and down. Go back this way. The trace will be coming down. But how would I get an angled line or a curve or any other kind of a path other than left and right or up and down? Well, if you've ever used one of these before, you know that the trick is to move each one separately or together actually, so that we're moving in a diagonal line or maybe simulating a curve by turning them both at the same time. And so what we find is that we can generate left and right motion by letting x depend on a variable like the position of the knob. We can do the same with y vertically, but if we combine them together, we can get motion in both directions, left, right, and up and down, which can give us diagonal lines, curves, stair steps, all of these different types of things. This little demonstration right here sort of automates the process. In other words, I can put an equation or an expression, more accurately, into this box here, and the horizontal knob, this knob here, that makes the trace go left and right will be controlled by this equation, and the vertical position will be controlled by this equation. And so you notice that both the horizontal, which is x, and the vertical, which is y, both depend on this variable t. This variable t is called the parameter, and these equations are called parametric equations. The parameter actually drives both the x and the y position. So as time, t, moves on, in this case from 0 to 1, what we'll see is that the horizontal position will vary from 0 to 8, since when t is equal to 1, h will be equal to 8. Same thing over here with the vertical position. Now in this case, both of these will be changing depending on the value of t. And so I would expect to get a path that's not strictly horizontal or strictly vertical, but somewhere in between. In fact, since these are both linear, I will end up with a straight line at an angle, and the slope, in fact, will be 5 divided by 8. So let's just go ahead and run it and see what happens. So you can see the horizontal position is changing a little bit faster than the vertical position, and so that's giving us a line with a slope of 5 over 8, a little bit less than 1. Okay, well that's interesting, but maybe not. Maybe it's actually pretty boring. Let's see if we can find something a little bit more interesting to illustrate this whole idea of parametric equations. Okay, so this time I've replaced the equations with these two. The x position, the horizontal position, will be controlled by a cosine function, and the vertical position will be controlled by a sine function. Now remember that cosine varies from -1 to 1. If I multiply by 2, that's going to vary from -2 to +2. And so the horizontal position will actually go left and right by 2 units past its home position. Same thing with the vertical position, it will go 2 units past. Now I've multiplied t by 7 in here, which is going to change my frequency, and that's basically going to set the speed at which the sine and the cosine function change values. I've also got a value of k, a vertical shift, of 3 in the case of sine, and let's see, 5 in the case of cosine. And so my home position, if you will, is actually going to be here at 3, 5. And so let's see what happens when we go ahead and start this thing up. And so you might or might not be surprised to see a circle. And the reason is because we have the horizontal changing by cosine, the vertical changing by sine, and that's basically our unit circle. And so the parametric equations can give us fairly complex motion with simple equations. In fact, if I were to go into this equation, and let's change this 2 to a 4, for example, let's see what happens. I would expect now to get something like a circle, except in the horizontal direction, it's going to travel plus or minus 4 instead of plus or minus 2, and so this circle should be stretched out left and right. And in fact, once I start it and take a look at it, that traces out an ellipse. And so even the conic sections could be drawn using parametric equations, and actually perhaps simpler in form than the x squared and y squared form that we had been using before. Okay, so let's just take a look at some of the basics of parametric equations. A parametric equation is where we have two or more functions related by a common parameter. Usually it's time t, but it can be other things like perhaps an angle or really anything else. But most of the time we're going to be considering that to be time t. So for example, this set of equations is a set of parametric equations where x is going to vary according to t squared and y is going to vary according to 4t minus 7. So we call the parameter is t. Okay, time is the parameter, and each value of t gives us a different value for x and a different value for y. So we can think about this as making the position of a point, x, y, change as a function of time. And so if we do that, this is the location of the point, of the object perhaps that we're tracking, at any point in time. So we're just going to plug in a value of t to get an x position and a y position, and that will give us our xy point. Okay, so we'll go ahead and do a couple of examples here. First, let's go ahead and go through the process. If we're going to plot parametric equations, the way we do that is we choose the value of time that we're interested in. Now, oftentimes t will start at 0, which kind of makes sense if you think about time starting at 0. We'll plug that value into x of t and we'll plug it into y of t. That's going to give us two values, x and y, and those are going to be the xy coordinate of the object at the time t that we plugged in. And then we'll just repeat this for as many values of t as we want to use. So here's an example, and we'll go ahead and fill in the table and then plot the points. Let's take a look at what we have here. We see that the value of x is going to depend on t. And so let's go ahead and get the values of x for these four values of t. If we start with t equals 0, we plug that in and we get negative 2 plus 3 times 0. That's negative 2 plus 0. That gives us negative 2. Now we plug in t equals 1. We get negative 2 plus 3 times 1. That gives us positive 1. Negative 2 plus 3 times 2. 3 times 2 is 6. Along with a negative 2 gives us 4. And finally, for t equals 3, negative 2 plus 3 times 3 is 9. Negative 2 plus 9 gives us 7. Okay, let's go back now and we'll look at our values of t. And this time we're going to plug them into the y equation. So again, we'll start with 0. 3 minus 2 times 0 is going to give us y equals 3. 3 minus 2 times 1. 3 minus 2 is 1 for y. 3 minus 2 times 2 is 3 minus 4, negative 1. And finally, 3 minus 2 times 3, 3 minus 6 is negative 3. And so what we've just done is created a table of xy positions as a function of time. And so this is where it gets kind of interesting because we know how to plot these points. In fact, let's go ahead and do that. Our first point is at negative 2 and 3. Our second point is at 1, 1. Our third point is at 4, negative 1. And our last point is at 5, 6, 7, negative 1, negative 2, negative 3. Now normally we would just perhaps draw a line through these and say that that was our function, y as a function of x. But again, remember that x and y are both functions of time. And so what's really happened here is we have taken snapshots over time of the position of this object as it actually moves. In other words, this was its position at time equals 0. This was its position at time equals 1, time equals 2. and time equals 3. And so we can think about this as tracing out the path of an object that starts here at t equals 0 and moves along here up until the point where t equals 3. And so this is what makes parametric equations so powerful. What makes them powerful is the fact that we can plot not only the shape of a path here, but know where that object was along the path at any point in time. Okay, let's try one a little bit more complicated here. Now we have x and y both depending on these quadratic functions of t. And so again, we'll start at t equals 0 and go through t equals 3. At t equals 0, we'll work with the x. 0 minus 1, we do inside the parentheses first. 0 minus 1 is negative 1. We square that, we get positive 1. 9 minus 1 gives us 8. T equals 1 rather. 1 minus 1 is 0, so 9 minus 0 gives us 9. T equals 2. 2 minus 1 is positive 1. Squared is still 1. 9 minus 1 is 8 again. And then 3 minus 1 is 2. If we square that, we get 4. 9 minus 4 is 5. Doing the same thing with y, we end up getting y equals 2, y equals 5, y equals 6, and again y equals 5. Alright, so let's go ahead and plot these points and see the path that this object is taking. Our first point will be at 8, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. And then we're going to go to 9 and 5, 3, 4, 5, 8 and 6, and then finally 8, 7, 6, 5, and well, let's do it this way. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and those are the points. And so that looks like just a scattering of points here, but in fact, again, we know that this is at time equals 0. Time equals 1, time equals 2, and time equals 3. So we know how to connect these points together, and more importantly, what direction we're going. So let's go ahead and do that. We'll start here. This object is actually going to go in this kind of a path here. And this actually turns out to be a parabola as it moves along in this particular pathway. Okay, so let's just review once again. To plot parametric equations, we're going to choose a value of t, and then we're going to plug that value into the x equation, and we're going to plug it into the y equation. That's going to give us two numbers, x and y. That becomes the coordinates of the point. Where is that object at that time t? And then we'll do that for as many values of t as we're given. And again, the examples that we did, here is two linear parametric equations. Gave us a straight line traveling from here to here as time went from 0, 1, 2 to 3. And the second example we did was actually a parametric or a parabolic curve starting at t equals 0 here, t equals 1, t equals 2, t equals 3, moving in a curved fashion.